March 14th, 1786. Dawn breaks over the River Tay in Perthshire, Scotland. The water curves through a hairpin bend so sharp it nearly folds back on itself, creating something engineers would later call a natural battery. A geological accident that concentrates an entire river's power into one compact turn. Richard Arkwright stands on the bank. He's 63 years old, wealthy beyond measure from his cotton empire, and he's looking at this bend like a prospector seeing gold. Not the water itself, the potential locked inside its momentum. Behind him, masons are already laying foundation stones. They're building something unprecedented, a mill designed never to stop. The math is brutal. 107 feet of elevation drop across the bend, millions of gallons per hour. If harnessed correctly, this single curve could power machinery that would employ 800 workers, making it one of the largest industrial sites in Britain. But Arkwright sees further. He sees not just a mill, but a philosophy. Every bearing must be accessible without disassembly. Every steam pipe union placed every 10 feet. Every system designed so no single failure halts production anywhere. The entire complex architected around one principle: continuous operation. This isn't just industrial ambition, it's a declaration that human ingenuity could outsmart entropy itself. The first building rises, the Bell Mill, named for its bell-shaped roof, visible for miles. Workers call it the beating heart. Inside, Arkwright's water frames, the machines that made him famous, line the walls in precise rows. Each frame connects to a central drive shaft powered by water wheels below. The lade system channels River Tay water through carved stone channels, directing flow with mathematical precision. The genius isn't the machinery, it's what happens when something breaks. A bearing seizes in Manchester Mills? Shut down the line. Replace the bearing. Lose a day's production. At Stanley Mills, bearings sit exposed on external housings. A maintenance worker can reach any bearing with one wrench. No disassembly, no downtime. Production continues while repairs happen around it. Steam pipes run overhead in sections. Every 10 feet, a union joint and isolation valve. A leak springs? Close 2 valves. Replace that 10-foot segment. The rest of the system operates uninterrupted. No one thought in segments before Arkwright. Everyone does now. The Highland Clearances are emptying the glens. Families displaced from ancestral lands arrive in Stanley Village with nowhere else to go. The mill absorbs them. 800 workers at peak operation, spinning, weaving, maintaining, building. Children work alongside adults, a practice that won't be questioned for decades. The human cost of continuous operation rarely appears in engineering journals. But something unexpected develops: a culture. Workers who maintain the same machines for 30 years learn their rhythms. They hear when a bearing sounds different, feel when belt tension shifts, smell when oil needs changing. The mill doesn't just employ them, it teaches them, and their knowledge feeds back into the design. When the East Mill rises in 1787, it incorporates lessons from Bell Mill's first year. Drive shafts positioned for easier maintenance, bearing housings standardized so parts become interchangeable. The architecture evolves through observation, not theory. By 1799, Stanley Mills operates 6 days a week, 16 hours per day, powered entirely by water. The lade system becomes legendary. 700 meters of stone channels delivering precise flow rates regardless of seasonal variation. Engineers visit from across Europe to study it. They're not impressed by volume, they're impressed by consistency. Then 1823 changes everything. The steam engine arrives. Not to replace water power, to supplement it. During drought, when the Tay runs low, steam boilers kick in. The machinery doesn't know the difference. The same drive shafts spin. The same frames operate. But the mill never stops for weather. This hybrid approach becomes the template. Other mills choose sides, pure water power or pure steam. Stanley Mills refuses the binary. It uses whatever works. Pragmatism over ideology. Victorian expansion brings the mid-mill and east mill additions. 5 stories of spinning machinery. But the principle holds. Modular construction, accessible systems, designed for repair. When structural engineers survey it in 1856, they find something remarkable. The original 1786 bell mill foundations are still sound. The building grew around them without requiring demolition and rebuilding. You can expand without starting over. This seems obvious now. In 1856, it's revolutionary. The workforce peaks at 800. Stanley Village exists entirely to support the mill. Housing, schools, shops, all built in proximity. When the morning bell rings at 5 a.m, the sound carries across the Tay Valley. Everyone knows what it means. The machines are waiting. Inside, Victorian spinning frames have replaced Arkwright's originals, but the maintenance philosophy persists. Every pulley belt accessible, every gear mechanism exposed. The building itself becomes a three-dimensional instruction manual. Look at how it's built and you understand how to fix it. By 1900, electricity arrives, not as replacement, but as addition. Water turbines now generate electrical power that runs electric motors that drive the same mechanical systems. 3 power sources, water, steam, electric, operating in parallel. Anyone can fail. Production continues. 2 world wars, the mill adapts. Cotton fabric for military uniforms. Later, specialised industrial textiles. Workers who started in 1910 retire in 1960, having maintained the same sections for 50 years. Their sons and daughters take over. Knowledge transfers through apprenticeship, not manuals. Then 1989. The announcement no one expected. Stanley Mills will close. Not from decay, not from obsolescence, from economics. Cheaper synthetic fabrics, international competition, changing markets. The machinery still works. The building still stands. But the business model no longer fits the modern world. 203 years of continuous operation, over 75,000 days, across 10 generations, the longest-running cotton mill in Scotland, possibly in Britain. Most mills would be demolished. Stanley Mills becomes something else. Historic Scotland recognises what's here, an intact industrial ecosystem, not reconstructed, not restored to pristine condition, intact, complete with oil stains, repair patches, improvised solutions accumulated over 2 centuries. The building tells its own story through modification layers. The restoration team faces a philosophical challenge. Do they return it to 1786 condition, erasing Victorian and modern changes? Or preserve the palimpsest, all eras visible simultaneously? They choose the palimpsest. When you walk through Stanley Mills today, you see Arkwright's original stone walls, next to Victorian iron columns, next to 1950s electrical panels. The maintenance culture becomes the museum's central narrative. Every improvised repair, every upgraded system, every adaptation preserved as evidence. The Europa Nostra award arrives in 2007, Europe's highest honour for cultural heritage conservation. The citation specifically mentions preservation philosophy, maintaining authenticity through visible history rather than artificial perfection. Today, the machinery operates, not for production, for demonstration. The original 1880s spinning frames still function. Volunteers who worked the mill before closure return to run them. Their hands remember, muscle memory from decades of operation. The lade system still flows, 700 metres of 18th century stone channels delivering River Tay water exactly as designed. Civil engineers study it for graduate courses, an operating example of pre-industrial infrastructure outperforming modern equivalents in longevity. You can reach every bearing without disassembly. The steam pipe unions still sit every 10 feet. The zero downtime design philosophy persists in the architecture itself. What Stanley Mills proves isn't about cotton or water power or Victorian industry. It's about what happens when an entire system is designed around one question. What if we never stop? Every decision flows from that question. Bearing placement, pipe segmentation, modular construction, interchangeable parts. The maintenance culture emerges from the maintenance requirement. When 800 people spend decades keeping one place running, collective intelligence compounds. Modern engineers visit Stanley Mills and see their own principles reflected back from 1786. Accessible design, designed for repair, redundant systems, graceful degradation. These aren't new ideas, they're rediscoveries. The Hairpin Bend still concentrates the Tay's power, the Bell Mill bell tower still marks the skyline, and somewhere in the stone walls, oil stains from 1823 sit next to marks from 1923, next to notes from 2003. 203 years of people refusing to let it stop. That's the lesson. Not that it lasted, but how it lasted. Through philosophy, not just engineering, through culture, not just design, through the accumulated wisdom of generations who asked daily, how do we keep this running? The answer is written in every accessible bearing, every segmented pipe, every modular system. You design for continuation. You build in the assumption that things will break. You create space for human intelligence to intervene. Stanley Mills didn't survive because it was perfect. It survived because it was designed to be imperfect, and maintainable anyway. The river keeps flowing, the machines keep turning, and the story keeps teaching.